So here in 3.7, we're revisiting the quadratic formula. You guys have seen this before in Algebra 1. If you remember it or not, it's okay. We're going to get a refresh on it. But what's new this time around with quadratic formula is now you can take the square roots of a negative. Right? We learned a few days ago that the square root of a negative makes I, or imaginary numbers. And so now we're very all of a sudden curious or fixated on what's going on in the root. Because if it's the square root of a negative, I'm going to have some imaginary solutions or non-real solutions. So that part inside the root, we have a name for it. It's called the discriminant. And it's very special because it tells us what kind of solutions we have. So there are questions coming your way, and even SAT questions that hinge on this concept. This is one of those that pops up with pretty dependable regularity on the SAT, where they give you a quadratic and they're like, how many solutions does it have? What kind of solutions does it have? And you just have to know that that's quickly determined by this part of the quadratic formula called the discriminant. Okay, so how do we use the discriminant to determine the types of solutions? If the discriminant is greater than 0, then that means that quadratic is making, or that equation is making two real solutions. So this is a positive discriminant, positive, greater than 0, positive. Two real solutions. If the discriminant, b squared minus 4ac, is negative, less than 0, negative, then you have two imaginary solutions, or the SAT likes to call them non-real. Imaginary solutions. And then what's the only number that's neither positive nor negative? 0. So if your discriminant is 0, then that is one real solution. Okay. We'll get to that in a minute. Which of these types of solutions makes x-intercepts? Real or non-real? Real. So when we say two real solutions, we should expect those to pop up as x-intercepts. And the imaginary ones do not. Now, the b squared minus 4ac equal to 0, that bottom possibility, making one real solution, that would be one x-intercept. And let's imagine what that would look like. That would be the vertex hitting the x-axis, either from below or from above. But it would be hitting the x-axis, it would be right there on the x-axis, bouncing off of it. Okay. Now somebody asked what I mean by double root. I mean x squared has two solutions, typically. That exponent squared, you'll learn when we get to polynomials, that tells us how many possible solutions this equation could have. And since it's x squared, there are two possible solutions. But if this is the scenario where it's bouncing off of, or the vertex is on the x-axis, then that means that one real solution is counting double. It's counting for both. An x squared equation has two answers. It's counting for both of the answers, so to speak. Okay. You'll really dive deep into that in pre-cal. Okay. So this is how we're using the discriminant, but let's first get some practice using the quadratic formula and refresh ourselves with that. So we have x squared plus 3x equals 2. Remember, we cannot endeavor into the quadratic formula until we have it in standard form. So subtract the 2 over to the left side. And then you'll want to jot down what your a, b, and c values are. A equals 1 in this case, right? 1x squared. B equals 3, and c equals negative 2. And then, do you want to know the safest way to plug numbers into a formula? Yeah. Using parentheses. Okay, play it safe, use those parentheses. So here we go, x equals negative parentheses b, right? Plus or minus the square root of parentheses squared minus 4 times parentheses times parentheses. You see where I'm going with this? Right, an overuse, a ridiculous amount of parentheses, because these negatives, simple mistakes happen with the negatives, with the squaring, okay? So you just use those parentheses to play it safe if you're a simple mistakes kind of person like me. Okay, and then plug those those numbers into your parentheses. So negative b, so 3 in for b, and then 4ac on the inside of the root, so 4 times 1 times negative 2, and then 2 times a on the bottom. And remember, you have a calculator for this, so if the numbers are pretty ugly, you can use a calculator. If you trust yourself, you can try to do it in your head, but you've got a calculator there at your disposal. If you're going to use a calculator, plug all of this in to the calculator, not the root part, just the part inside the root. Just remember, in our TI-83 calculators, there's a different button for minus and negative. So it's minus 4 right here, but this is a negative 2. Minus is right above the plus button. The negative is on the bottom row next to the enter button. Don't mix those two buttons up. All right. So you get 17. Did you guys get 17? Anybody do it with me? Over 2. So negative 3 plus or minus root 17 over 2. And then you could write that, you could split up the denominator, negative 3 over 2 plus or minus root 17 over 2. Either answer form is fine by me. Okay, there's your quadratic formula. Remember that guy? Not so bad. Hey, here's the thing though. The quadratic formula works for every quadratic. And your Algebra 1 teacher might have told you to use it on everything, because that was an easy way to explain it. And I get why they did that. You were younger, your brain was still developing. That's fine. But you're an Honors Algebra 2 student now. And if you use quadratic formula on every problem, you're going to run out of time. So this lesson is about you practicing using it. But when it comes time for quiz day or test day, and the instructions say, solve this using the most efficient method, you better be able to identify the most efficient method and pursue it. Not spinning your wheels in the mud trying to use a method that's going to take you way too much time. Okay? Okay. Try number 2 on your own. I'll put my answer up there in a moment. Don't forget to get it into standard form before you start trying to do any kind of solving method. Okay, so there's my answer up there. And the instructions did say, do quadratic formula. So I did solve it using quadratic formula. And it was a neat case study. When I did this discriminant part in the calculator, I got 0, which was my indicator. I'm going to have one answer, one real solution, because I know the discriminant. If the discriminant is 0, I know I've got one real solution. So I was not surprised at having one solution. And why did I end up having one solution? Because plus or minus 0 is nonsense. That all goes away. There is no such thing as plus or minus 0. So when you get that 0, the plus or minus becomes irrelevant and a non-factor. Okay. But this is also what I meant when I said to be on the watch for the most efficient method. I want you to be able to recognize perfect square trinomials like this, so that you can factor it nicely into 4x minus 5 squared. Take the square root and solve for x. Like, this is a faster way than dealing with these giant numbers and having to take the time to put them in your calculator. And you're like, when would I ever use this? This is literally an SAT question. Literally. It's just, they gave you this, and then they said, which one of the following is the solution? Right? Or they gave you 4 sets of factors. And they wanted to see if you knew that this factored into this and how much time you were going to waste doing it. Okay? So you got to be able to recognize those patterns. Okay. Here, let's try one more. Why don't you try number 3? And if you want a hint, you can look up here. If you don't want a hint, don't look. But if you want a hint, you can look. Here's your hint. It's a very good one. It's the best hint. I've been working on this hint all week. Tremendous hint here. This hint is fire. So, I am going to get rid of these ugly fractions by multiplying both sides of the equation by 9. And you might be like, are you just allowed to do that? Yes. If you're solving the equation, yes. You can multiply both sides by whatever you want. If you were graphing, then no, you can't do that. You can't just randomly start multiplying numbers in there, changing the shape of the graph. But we're solving, we're not graphing. Okay. There's another little trick. I don't want to deal with so many negatives, so I multiply by -1 on both sides to get rid of the negatives, to change all the signs. Again, you're allowed to do that if you're solving. Okay, you would not be allowed to do that when you're graphing. So those are your final answers there, you know. And of course, you should check, you know, factor tree of 1079. And as we all know, that's simply 13 times 83, which are both prime numbers. So, you know, that's not going to break down anymore. I'm joking. No one knows the factors of 1079. Okay, I checked earlier. But that one doesn't break down anymore. No pairs in that factor tree, so it stays as root 1079. Don't forget your I, though. Your I doesn't stay in the root as a negative. It certainly doesn't stay in the root as I. It comes out right next to the root as a multiplier on the root. I times the root. Okay? So make sure you take care of that I. That's like the new thing for y'all. So don't forget that. That's like the point of all this. Okay. Number 4, 5, and 6 are asking us, instead of just solving, they just want us to simply use the discriminant, find the discriminant, and use it to determine the number and types of solutions of the equation. So the discriminant, it's just one of those things you've got to know. And to be honest with you, I and the SAT will not tell you, okay, use the discriminant. I'm just going to ask you, how many solutions does it have? Or what types of solutions does it have? And you've got to know that that's dealing with the discriminant. And you have to know what the discriminant is. There are no formula charts anymore. They're gone. It's all on you now. You've got to know the quadratic formula. You've got to know which part of it is called the discriminant and what the significance of that is. Okay, so we're still going to jot down what A, B, and C are. A equals 1, B equals 10, C equals 23. And we'll plug those into our discriminant. B squared minus 4 times A times C. 10 squared minus 4 times 1 times 23. And you can use your calculator, or you can do it in your head. You can roll that dice and do it in your head. Whatever. Go ahead and calculate it out. You do it. I already did it earlier, so I'm good. You try it. So you should get that for your discriminant, which means what? You have to be specific. Two solutions. What type, though? 2 real solutions. Question: would these real solutions be rational or irrational? Rational. Why? Wait, no, irrational. Why? Yeah, we didn't talk about that earlier. Rational versus irrational. Rational means can be written as a fraction. So your examples of rational would be like 2, -1, 1/3, 0. Those are rational solutions. Real rational solutions. They can be written as a fraction, right? Because rational, that comes from the word ratio, fraction. A ratio is a fraction. That's what it means. It's just fraction. And then irrational are things that cannot be written as a fraction. So those are your roots, like plus or minus root 3, or your 2 plus or minus root 7 over 3, something like that. So the way that you know that this is irrational is that this number cannot be square rooted. Okay. So if this is a perfect square, then you're dealing with rational real solutions. If this is something that cannot be square rooted, you're dealing with irrational. Okay? So square root Irrationals cannot. No. Cannot be square rooted. Rationals can. For the discriminant. I'm not talking about whatever the answer is. I'm talking about the discriminant. Okay. All right. So that's, I mean, those are pretty straightforward. Pretty easy problems. Why don't you try number 5 and 6 on your own, then check up here when you're done. All right, as you finish up with those, check your answers up here. So yeah, if your discriminant is negative, below 0, you get 2 imaginary. If it's 0, you have 1 real solution. If it's 2 real solutions, we'll specify if it's rational or irrational. Remember, that's rational and irrational is based on whether or not you can square root the discriminant. Okay. If you can square root it, you'll get rational solutions that look like these. If you cannot square root the discriminant, you'll get irrational solutions that look like these. Okay, let's do 2 word problems to wrap up our time together. A basketball player tosses the ball to a teammate. The ball leaves the player's hand 5 feet above the ground and has an initial vertical velocity of 55 feet per second. The teammate catches the ball when it returns to a height of 5 feet. How long is the ball in the air? Use this function. This is a fairly common function. This is a function that we use typically for objects that are falling due to gravity. And you get into this in your physics classes as well. So H in this function, the first H, stands for the height of the ball at any given time. It's H as a function of t at a certain time. Okay. T is obviously time, in this case in seconds, because the velocity is per second. The V sub O. V sub O is the initial velocity. Vertical velocity, to be specific. How fast that ball is going up. And then obviously as gravity does its part, the ball is going to slow down and begin to return to the ground. But here in our problem, the V sub O, initial velocity, vertical velocity, is 55 feet per second. And then H sub O is the initial height. That is not to be confused with the H in the beginning. Those are not the same H's. The initial height is an H that never changes. It's constant. Once the ball has left the player's hand, the height that it was when the story started cannot change. You can't go back in time and make the player hold the ball lower when they throw it. Okay? Like the height of the ball at the time of 0 is static. It will not change. So in this case, it's the initial height. This first height is always changing depending on what time it is. If it's toward the beginning, it's pretty low. If it's toward the middle of the flight, it's pretty high. Toward the end, it's going to be returning to the ground. Okay, so they're wondering at what time the ball is going to return to a height of 5 feet. Okay, so this is our H. This is the height that it's returning to later on. H of 0 is the height at time 0. Okay. So we'll plug these pieces in and then we'll solve however we need to. Our height with the initial velocity and initial height plugged in, our height equation goes negative 16t squared plus 55t plus 5. Graphically, that is this picture. We have our y-axis is height, our x-axis is time, and we're dealing with a parabola that's upside down because the negative in the front, and it has a y-intercept of how much? What's the y-intercept of this parabola? 5. How do you know? Because of the c value at the end, right? The c value right there. So we have a parabola that looks, I don't know, something like this. And this is the height of the ball as a function of time. The ball goes up as some time comes along. Eventually gravity forces it back down, and so eventually after some time passes, it hits the ground. This point right here is a height of 0. Okay. So we're wondering, not when it hits the ground, we're wondering when it returns to a height of 5 feet. We're wondering if this is the height of 5 feet, we're wondering when is it going to return to that height? We're wondering what t value is this? At what time is it going to return to 5 feet? So I'm plugging in 5 for height. In other words, I'm finding the intersection of a line called this parabola equation and another line called y equals 5. Does that make sense? I'm finding the intersection of y equals 5, or h equals 5, and h equals this parabola. And if I have two equations that are both h equals, then I plug them into, I set them equal to each other. So 5 equals negative 16t squared plus 55t plus 5. Okay, let's go ahead and solve this. We'll subtract 5 from both sides. Minus 5, minus 5. So 0 equals 16t squared plus 55t. You could plug this in the calculator, or you could, negative 16, excuse me, or you could use the quadratic formula. Since this lesson is about quadratic formula, let's use the quadratic formula. So we have A equals negative 16, B equals 55, and what is C? C is 0. Okay, so T equals, right, because T is our x. Usually the quadratic formula is x equals, so this is T equals negative B plus or minus the square root of B squared minus 4 times A times C over 2A. What is going to happen to 4 times 16 times 0?
0.
Yeah, 4 times 16 times 0 is 0. 0 times anything is 0, so all of that's going to go away. So when all of that's gone, and you could do it in your calculator, but you'll see this in your calculator. When all that's gone, I've got a 55 that's being squared and then square rooted. So what's that going to be? Just regular 55. So T equals negative 55 plus or minus 55 over negative 32. So I do negative 55 plus 55 over 32 and negative 55 minus 55 over negative 32. Obviously, negative 55 plus 55 is 0. So the first one gives you time equals 0, which is no surprise. Why is this not surprising for us? Yeah, because that was time. That was the start right here. That's the starting height. Of course the ball was 5 feet then, because that was the initial height. They told us that. Okay, but then later on at time 3.4375 seconds later, the ball reaches that same height again right here. Okay, which is quite a throw in basketball. I mean, you think about a basketball game. That ball hangs in the air 3.5 seconds. They launched it. That's like a full court pass with quite an arch. Anyway. Okay, why don't you try the next one, the juggler, and see how it goes. I'll put my answer up there in a second. Or actually, yeah, you try it out. I'll put my answer up there, and then you can get started on your homework. So there's, just kind of as you're working along, there's my setup. I got my equation, plugged in the right variables, and then you don't have to do a graph. I just think sometimes that helps people to see that. So there's a graphical representation of what's happening. I'm finding the intersection of a parabola that is intersecting a height equals 3 line, because I'm wondering at what time the height is 3. Okay, so there are your answers kind of as you finish up. T equals negative 0.025 seconds, which isn't a surprise, you know, like that's this spot right over here. That's this intersection. When time was negative, that's irrelevant for this problem, but that's why we're getting a negative answer there. And then again over here at 2.525 seconds. So a few people have asked how to plug it in the calculator, so I'll go ahead and end the video and then move over to that. If you're watching the video and you want to know how to plug it in, just come see me before or after school.